Now, let's look at a situation where we need to combine two differentiation rules. Sometimes a function is a product of two expressions, and each expression is also a composite function. In that case, we must use both the product rule and the chain rule. Let's find the derivative of f of x equals 2x plus 1 to the fifth times 3x minus 2 to the seventh. First, notice that we have two functions multiplying together. So this tells us we must start with the product rule. The product rule says we take the derivative of the first function multiplying by the second function plus the derivative of the second function multiplying by the first function. So I take the derivative of 2x plus 1 to the fifth times 3x minus 2 to the seventh plus the derivative of 3x minus 2 to the seventh times 2x to the fifth. Next, I need to differentiate 2x plus 1 to the fifth. This is a composite function, so we apply the chain rule. First, differentiate the outside power. Using the power rule, I have 5 times 2x plus 1 to the fourth power. And then multiplying by the derivative of the inside function. So this is the derivative of 2x plus 1 to the fifth. And multiplying by 3x minus 2 to the 7th. Next, I need to take the derivative of 3x minus 2 to the 7th. This is also a composite function, so we must apply the chain rule. First, differentiate the outside power. Using the power rule, I have 7 times 3x minus 2 to the 6th. Multiplying by the derivative of the inside function. This is the derivative of 3x minus 2 to the 7th. Multiplying by 2x plus 1 to the 5th. Now, I need to take the derivative of 2x plus 1, which is 2. Then I need to take the derivative of 3x minus 2, which is 3. Now, I have done taking the derivatives. All I do now is simplifying this expression. 5 times 2 is 10. 7 times 3 is 21. And this is the derivative of f of x. The important idea here is, first, recognize the function is a product, so we use the product rule. Then, when we differentiate each part, we apply the chain rule because each part contains a function raised to a power. So sometimes in calculus, we need to combine multiple rules together. Now, let's look at another example. We want to find the derivative of the function f of x equals sine to the sixth power of 2x to the third plus 1. Before we start differentiating, it helps to rewrite the function so that we can clearly see the layers. Remember, sine to the sixth of 2x to the third plus 1 means the same thing as sine of 2x to the third plus 1, the whole thing to the sixth power. This form makes it easier to see the structure of the composite function. Now we can see that this function has three layers. The outer layer is the power of 6. The second layer is the sine function. And the third layer, which is the inner layer, is 2x to the third plus 1. When a function has multiple layers, we apply the chain rule one layer at a time, working from the outside inward. To find the derivative of f of x, we need to start differentiating the outer layer first. The outer layer is the power function, so we need to use the power rule. We bring the 6 down as the coefficient, and the new exponent is 6 minus 1. So we have 6 times something to the fifth power, and this something is sine of 2x to the third plus 1. This is the derivative of the outer function, and we need to multiply this by the derivative of the inner function. Now, I need to take the derivative of sine of 2x to the third plus 1. The derivative of sine is cosine. Cosine of 2x to the third plus 1 is the derivative of the second layer. We need to multiply this by the derivative of the third layer. And the derivative of 2x to the third plus 1 is 6x squared. Now, I need to simplify this expression. 6 times 6x squared is 36x squared. And this is the derivative of f of x. A helpful way to think about these problems is start from the outside, take the derivative, and keep multiplying by the derivatives of what's inside. So when a function has multiple layers, we simply apply the chain rule repeatedly, moving from the outside toward the inside. Now, let's look at a different type of problem. Suppose h of x equals f of g of x, and we want to find h prime of 3. And we're given a table of x, f of x, f prime of x, g of x, and g prime of x. To find h prime of 3, we first need to find h prime of x. And h of x is a composite function, so we use the chain rule. We take the derivative of the outer layer, which is f prime of g of x, multiplying by the derivative of the inner function, which is g prime of x. To find h prime of 3, we plug in 3 for x. So h prime of 3 is f prime of g of 3 times g prime of 3. First, we need to find the value of g of 3. When x is 3, what is g? From the table, when x is 3, g is 1. So we will replace g of 3 with 1. When x is 3, what is G prime? From the table, when x is 3, G prime is 1. So we'll replace G prime of 3 with 1. Then now we need to find f prime of 1. When x is 1, what is f prime? From the table, when x is 1, f prime is 1. So we'll replace f prime of 1 with 1. So I have h prime of 3 equals 1 times 1. And 1 times 1 is 1. So h prime of 3 equals 1. The key idea is that the chain rule works even when functions are defined using tables or data, not just formulas. You still apply the same rule and then use a table to find the values you need.